Very good morning, dear students. I welcome all of you to the today's session. And this session, we are going to continue the discussion of chapter 4, that is presentation of data. We all know that to present the data, there are three forms or there are three types. First one, textual presentation, tabular presentation and diagrammatical presentation. In the previous classes, already we have discussed what is textual presentation and what is tabular presentation. And this session, we are going to continue with the diagrammatical presentation of data. Here, the third form of presentation of data is nothing but diagrammatical presentation of data. Here, very simple, diagrammatical presentation refers to presenting the data in the form of or with the help of pictures and figures or with the help of diagrams is nothing but diagrammatical presentation. Once again, I am repeating, diagrammatical presentation refers to diagrammatical presentation refers to presenting the data with the help of pictures, diagrams. Got it? This is what diagrammatical presentation is, presenting the data with the help of or in the form of pictures and diagrams or with the help of figures. If we are going to present the data, that is nothing but diagrammatical presentation. Here, the most very effective way of presentation is diagrammatical presentation when we compare with the textual as well as tabular presentation, because only the educated people can able to understand the textual and the tabular presentation of data. But when we present the data with the help of pictures and diagram, even the illiterates or the uneducated people also can able to understand the diagrammatical way of presentations. For example, if we tag the board like no smoking zone, then only the educated people can read this and they can only understand this, right? But when we use the picture instead of this words, like then everyone can easily understand. Here there is no smoking zone or it is a no smoking area, and don't use oral, do not use oral. Okay, but only the educated people used to read this code and they can only understand. But instead of this, if you use, okay, likewise, if we are using figure, you should not make a noise. It's in a particular hospital zone or it is a school zone. They used to write, should not use orals. We should maintain the silence. Likewise, they used to write, but only educated or somebody can understand. Everyone cannot able to understand. But when we use the figures or pictures to present the data, that is most effective than the textual and tabular presentation. That's why we will tell the most convenient way of presentation of data is diagrammatical presentation. Got it right? And here the diagrammatical presentation we are again going to bifurcating into the three types. The diagrammatical presentation we are bifurcating into 3 types. What are the 3 types is there are 3 types of diagrammatical presentation. What are the 3 types? In the sense, the first most important diagrammatical presentation is geometrical diagrams, and second one is frequency diagrams, and third main one is arithmetic line graph. These are the 3 forms or 3 types of diagrammatical presentation. First one geometrical diagrams, and second one frequency diagrams, and third one arithmetical line graph. Second one frequency diagrams, and third one is arithmetic line graph or diagram. Arithmetic line graph, or we call it as arithmetic line diagram. Got it? These are the 3 forms of diagrammatical presentation. Now we will discuss about geometrical diagrams. Understood, right? The meaning of diagrammatical presentation is diagrammatical presentation is presenting with the help of pictures and diagrams. And diagrammatical presentations there are 3 types or 3 forms. What are that? First one is geometrical diagram, second one frequency diagram, and third one is arithmetic line graph. Now we will discuss about how to present the geometrical diagrams. Geometric diagrams. Here, the geometric diagrams, again we are going to bifurcating into 2 parts. One is bar diagram, and second one is pie chart. Maybe you are studying your 10th. The geometric diagrams, again we are classifying or bifurcating into 2. One is bar diagram and second one is pie chart. Here, bar diagram is the sense very simple. It is a group of bar diagram is a group of equidistant or equispaced rectangle bars for the each class of data. Understood? Here bar means the equidistant or equispaced rectangle bars for each class of data. And here the width of the bars, the width or the length of the bars will be same for the each bar, but height or the length, the length of the bar will be depends on the data. Here the width is equal for each bar, but height or length will be differ from one bar to another bar, or one rectangle to another rectangle. Here the length or height will be depends on the data. Understood? Here the bar diagram is, it is a group of rectangle bars which have equal space and equal distance. Equal space and equal distance for the data. But here one thing we should be noticed, that is the width of the bar. It means the distance of the bar will be same, but height or length will be depends on the variables. Depends on the variables. Got it? This is what bar diagram. Right now, bar diagrams. Bar diagrams comprises with distanced or equi spaced rectangles for each class of data. And here the width of bars are same, but length or height of the bars depends on values of the data. Are you understood? Bar diagrams are comprised with the equidistanced or equispaced rectangles. Equidistant or equispaced means if the width of one bar is 1 centimeter, that will be applicable for each bar. All the bars width will be 1 centimeter only. Or if we are taking one bar width as one rectangle width as 2 centimeter, then width of all the rectangles will be 2 centimeter only. But the height of the bars will be depends on the value of a variable or the value of one data. Understood, right? This is what bar diagrams. Again, in the bar diagrams, we have three forms of. There are so many, but mainly here we are going to discuss the three forms of bar diagrams. What are the three forms of bar diagrams in the sense? First one, simple bar diagram, and second one, multiple bar diagram, and third one is component bar diagram. These are the three forms of bar diagram. Got it right? Diagrammatical presentation in three forms. One is geometric diagram, frequency diagram, and arithmetic diagram. Again, the geometric diagrams are two types. One is bar diagram and one is pie chart. Here, bar diagrams are nothing but it comprises with equidistance or equispaced rectangles for each class of data, and the width of bars or rectangles will be same, but length or height of the bars depends on the values of a variable or data. Again, here. What are the three forms of bar diagrams means? Simple bar diagram, and second one multiple bar diagram, and third one is component are the percentage bar diagram. Understood, right? Now we are going to discuss the simple bar diagram. Understood, right? Here now under the bar diagrams we are going to discussing the simple bar diagrams. How to draw a simple bar diagram for the particular data. Now we are going to discuss. Here, simple bar diagram is the simplest form of bar diagram or easiest form of bar diagram, and here we are going to presenting only one variable. Under the simple bar diagram, at a time we can only present any one variable data. For example, sales of a company, or income of the persons, or the population rate of any one country, or the production of particular product. Likewise, any one variable data we can present for a particular diagram. That is nothing but simple bar diagram. Understood? Simple bar diagram is the simplest or easiest form of bar diagram, and under the simple bar diagram you can able to present only any one variable. We can present any one variable data. Understood? The simplest form of bar diagram. It is a simplest form of bar diagram, and it is helps to present any one variable or category of data. Got it? Here it means simple bar diagram is the simplest form of the easiest form of bar diagram, and it helps to present any one variable or one category of data at a time. Got it? And for example, or for instance, population or production, income, sales, or profit rate, etc. Likewise, any one variable. For example, if we have chosen simple bar diagram, we can present the population in that, or production, or income, or sales, or profit. Likewise, any one particular variable we can able to present in the simple bar diagram. It's the most easiest form of bar diagrams. Understood? Now we'll going to discuss with the bar diagram with presentation. Got it? Take one question for this. Now they will ask likewise. Okay, they will give one particular data and they will ask you draw a simple bar diagram. Take example question. Question number 1. Draw a simple bar diagram for the following data relating to the population of country in a different census of years. Draw a simple bar diagram for the following data relating to population of a country in different census years, or census of years. Okay, and here they will give one chart. They will only give the data years, population, 1951, 1961, 1971, 1981, 1991, 2001, and one more 2011. 6.1 crore, yeah, 43.9 crores and 54.8 crores in 1971, and under the 1981 the population rate was 68.4, and under the 1991 84.4, and in 2001 102 crores, and here 121 crores. This is what the population rate of country in a different census of the years. For this data we need to present in a simple bar diagram. You understood the question, right? Draw a simple bar diagram for the following data relating to the population of a country in different years. They will give a data. For this data now we need to draw a simple bar diagram. Now we will move to the diagrammatical explanation. You maybe know about the space of the diagrams, right? We will be having a 4 angles. These angles we will be dividing into x. Whatever the values we will be measure here, that indicates plus x values, and here this is y, this is x. Here plus x value plus y value, here the minus x values, and here the minus y values we will be present. Here both plus. This angle shows the plus values of, means positive values of a axis as well as positive values of a y axis. Understood? Here positive y axis, y variables negative y variables we will be having. Here again minus y, negative means negative y, positive x. Got it? We won't take these three angles for the diagrammatical presentation. We are going to take the one angle, that is this particular angle we are going to take for the diagrammatical presentation, and we are both the axis will be measures the positive values. Both the x-axis also measuring the positive values and both y-axis, it means the y-axis also measuring the positive variables. Got it? And before going to presenting the data in the diagrammatical form, first we need to give a title. What title can we give to this diagram? Population rate of India. We can give, okay, because what the diagram is going to presenting, the title will be relating to that particular data. What is population rate of India. Yeah, we are going to take positive y as well as positive x-axis. Zero, always it starts from 0. This is 0 angle. This is x-axis and this is y-axis. Understood? This is 0 to x-axis, 0 to y-axis. Always keep in your mind the variables, it means the changing factors usually we measures in the y. The changing factors are the variable factors we will be measuring the y-axis, and the constant factors or the variables we will be measuring in the x-axis. Keep in your mind the constant factors or variables usually we are used to measure in the x-axis, and variable factors we used to measure in the y-axis. Here, which is the variable factor? The variable factor is population, right? Then the population we are going to measure in the y-axis, and the constant factor like years we are going to measure in the x-axis. And you keep in your mind we are going to measure in the rectangles. Rectangles means we need 2 points for each bar. 2 points for each bar, and the bar distance or the width will be same for the each bar. Got it? That's why if you have a scale, you can use it. Take 1 centimeter gap from 0 to first point. 1 centimeter gap. Again take 1 more centimeter gap. Likewise take 14 points now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Got it? Mention here what we are measuring in the x-axis. We are going to measure in the population, right? Population rate. And what we are measuring in the y-axis? Sorry. In the x-axis we are measuring the years, and in y-axis we are measuring population rate. Now, before going to take a points relating to a population rate, you must observe the data. You must observe the data like okay, the classification of data we have taken the class interval to present the data in particular form. In the same way, here also we have to take class interval. The minimum value starts from 36 and the maximum value is 121. Then if we have to take a class interval as a 10, it means the distance between one point to another point. Now we are going to take the distance between one point to another point as a, we can take as a 5 as a class interval, or 10 as a class interval, or 50 or 20. But the distance between each one point to another point will also be same. Got it? We can take difference or class interval as a 5, 10, 15 or 20. Now we are having the values are up to 121. But if you take 10 as a class interval, it will going to end with only 100. But we need to reach up to the 121. Then we take now the class interval as a 20. 20 means 0 to first point 20. Here also, whatever the space we will take for the first point, the same space will be continued for the each points. Got it? 20, and the same distance will be applicable for the next also. 40, same distance will also be taken. Then 60, 80, 100, 120, 140. Understood now? Here the scale 0 to 20 means if we have 10 value, then the exact center will be 10. If you want 5, you need to take 5 as between this two. If you have value equals to 15, then it will be, it appears here. The scale we should be know exactly to measure the values. Got it? Now come to measure the values. Now first here is 1951. In the 1951, the population rate is 36.1 crore. Here where the 36 is appearing, 40 to 20 between that will appear 30. Okay? 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Here, this is what? 35. Got it? This is 30. This is 25. Here, most likely the 36 used to appears. Then take this particular point. Take this particular point here. Okay, from this point to here. Take with the help of scale, draw one line and take a rectangle and touch with the next point. Okay, this is what first rectangle. It's showing the population in 1951. And next bar is relating to 1961. Here under the 1961, we have a 43.9 crore population. Here 43 means this is what 50. 1, 2, 3, 4, 5. Here after the 40, 1, 2, 3, 4. This is what 43, right? And take one equal point, equal measurement, touch with the next point. 30, this is what? Next rectangle. And this is relating to 1961. Come to the next bar, 1971. We have a 54.8 crores of population. Here 50 means it is between 40 to 60. Here 50 will appear exactly here. 54 means 1, 2, 3, 4, 5. This is what 50 and 55. Below slightly the 54 used to appear. Then take this value to here now. Got it? Next come to a 1981. This is 1971. Next 1981 we have a 68.4. Now 68 means this is what 70, 61, 2, 3, 4, 5, 65, 66, 7, 8. This is what 68. Then take this measurement till here. Now come to the next bar, 1991, 84.4. 84 means 81. This is what 90. 84 means 81, 82, 83, 84. It will appear here. 84 means. Take now. Then move to the next. 2001 we have 102. 102 means slightly above the 100. We will get 102 because it is 110 and 105. Here we will be having 102 above slightly to the 100. Got it now? Then come to one more 2011. In 2011 we have 121 crore of population. 121 means slightly above the 120. Take 1 point above 120. Then it is what? 121. Then draw a diagram. Mention here the years which the bar going to present. This bar going to present 2001. This is 2011. Okay. This is what the simple bar diagram. We are measuring only one variable at a time. And now you maybe understand that. Okay. Equispaced or equidistanced rectangles is nothing but bars, right? You see the space between each bar is also same and the distance or the space of each bar is also same. The distance as well as the space of bars are always same, but length or the height of a bar is depends on the values of a variable or data. Based on the values, the length of a bar will be determined, but the width or the space of a bar will be always same. If you take 5 cm space, then each bar space will be 5 cm only. Or if we take 5 cm as a width of a bar, then each bar width will be 5 cm only. Or if we take 1 cm, then width of each bar will be 1 cm. Are you got it? The width and space will be always same for the each rectangle, but length or height of the rectangle will be depends on the values of a data. And also, after drawing this, to make attraction of this diagram, we can use any one particular shades. I have given star borders. If you want, you can mention how much the bar is going to be 84.2 and 102 or 102 and here 121. This is what bar diagram, that is simple bar diagram. Got it now? Next class we will be going to discuss the one more type of one more bar diagrams. Got it? Thank you everyone.